So hey folks, here I am in my office. It's Thursday afternoon, about 3:35, and I think I have the assignment ready for tomorrow. So let's go through that. Here we are in As You Learn. I'm going to scroll down to this week, and there's the lab assignment. Lab assignment number 4, chapter 10. If you click on that, this will be live at 5 o'clock. Right now I can preview the quiz, and I'll start the attempt. And there are 12 questions, and the first 4 ask you to use the Zillow data. And we're going to do a paired comparison t-test. And so the first question asks you to estimate the mean of last year's home value index. The second one asks you to estimate the mean of the current home value index. The third one asks for the t-statistic from a paired 2-sample difference in means test. And then the fourth one, I want y'all to take a look at the alternative test where you naively conduct a 2-sample difference in means test where you're naive because you don't realize that this is a before and after comparison, or a comparison from last year's home values to this year's home values. So I'm going to keep going on the preview, and we'll look at the data in just a second. So the next 4 questions, we're looking at the BSG data. And here we are conducting a 2-sample t-test. We've done this before in a lab, I believe, or at least in a problem set, but this is going to lead to it's setting the context for an f-test looking at differences and variances. So the first thing I'm asking is for you to estimate the mean expenditures on the blood, sweat, and gear strip itself. So the variable is BSG EXP. You need to sort the data on whether they rode the century or not. The century is the 100-mile route, and the non-century, when century equals 0, is a 50-mile route. So the second question on this set is, what is the mean expenditures for those who rode the 100-mile route? Then what's the t-statistic for the difference in means of expenditures? And the key assumption here is assuming unequal variances. And then what is the t critical value, as if conducting these hypotheses tests are the most important thing, but hopefully we'll see how that's important. The next question, what's the confidence level in this test? Okay. And so the next set of questions is looking at the comparison of the variances in expenditures for those who rode the 50 and 100-mile routes. And so I see that the first thing I need to do when the video is over is move question 11 up to question 10. So I want you to first conduct a folded f-test for differences in variances of expenditures. And then the second question is, what is the confidence level in this test? And then the third question is, considering the test for differences in variances, is the unequal variances assumption appropriate in this test? And there's 2 answers, yes and no. And on this quiz, you get 2 chances to get the question correct. And so hopefully you'll get question number 12 correct. But I want you to see how the answer to that is related to 10 and 11. Okay, so let's go back to the course, and we'll first look at the Zillow data. And Zillow is a real estate website, and they do a real good job with collecting real estate data all over the country and making that available. So here is the Zillow data that we have. You see it's organized here in the metropolitan area. So it starts at Akron and it goes all the way down to Youngstown, Ohio. And so this is the average value for all homes in these metropolitan areas. And we have the home value index for last year and then the current home value index. And the year-over-year change is this last column, but we won't be using that for this exercise. And I think these data were collected, I think I downloaded these about a year and a half ago maybe. So with the Zillow data, let's see if I can make this thing, this guy a little bit smaller. There we go. So we want to data analysis. Would it be right there? Nope. Now I've lost my thing. So this is embarrassing. I don't want to stop this video. Show toolbar. All right. I'm going to close out of there and open it back up, and hopefully my toolbar will be there. I couldn't find my data analysis tab, but it's not. So open this up. All right, so there I got the commands back. And there's the data analysis. Goodness, that was pretty embarrassing. So data analysis, and we want to conduct the paired two-sample for means test. So click OK, and we have the variable 1 range and the variable 2 range, and we're looking at the current and the last year home values. So I'm just going to do this for a subsample of the data, and I want y'all to do it for the whole column, the whole country. So let's call variable 1 the last year data, and I'll go down to Boulder, Colorado. And then for variable 2 range, we'll do the same thing for current year data. And I highlighted the third row, so we have labels there, and just go click on OK. And the result pops up in another window. Make that bigger. And I'll make that dollars. So, whoops. So last year's average home value index for the first 21 metropolitan areas in the data set was 168,500, and currently the average value index is $181,000. And the T statistic is negative 4.48, which means that last year is less than this year's. The p-value, or the critical two-tail value, is 2.09, and so negative 4.48 in absolute value is way above that, so we'd say that's statistically significant. And the p-value has a bunch of zeros to the right of the decimal, and the confidence that we have in that is going to be 1 minus the p-value. And in percentage terms, we're 99.98% sure that the current home values are higher than last year's values. Okay, and to compare that to the test where you assume that there's no relationship between home values in Akron last year and this year. Let me go back over here. This T statistic is going to be higher than the next statistic that you estimate because of the correlation between these two values. We've talked about correlations in the past, but the values before and after, or last year and today, across these cities, they correlate about 99%. So that's going to affect the hypothesis test. So if you do data analysis, and for the last question in that group, if you do a 2-sample t-test with unequal variances with the same variables included, with labels, okay, so F to F, oh. So there we have column E and column F instead of column F and column F. Click OK, and the t-stat we get is much lower than you saw before. And so if you do the incorrect test, you're going to conclude that last year's values are not different from this year's values because you have so much correlation across the two columns that's not being accounted for by pairing the two values and taking the difference and doing the test on the difference. Okay, so hopefully that gets y'all going with the Zillow data. For the BSG set of questions, go all the way back up to the last week of August and download the BSG data. And this is data that you've seen before. These are folks who come to Boone to train before the Blood, Sweat, and Gears event. And we have people who actually participated in the Century, if it's equal to 1, or if they rode the 50-mile route and they're equal to 0. Okay, the key variable that we're testing is Blood, Sweat, and Gears expenditures. So person 1 over here spent $130. Person 2 spent $450. Okay, so to do the difference in means test and the variance test, you're going to need to sort the data. So highlight the whole spreadsheet, click on data, and then click on sort. And it wants to know which column that you want to sort on. So we'll sort on Century and click OK. So here we have 17 people in the sample who rode the 50-mile route, and then 67 people who rode the 100-mile route. So do the tests that are in the lab assignment for the whole sample. I'm just going to do it for the ones that we see on this screen. Okay. So that we can see everything a little bit easier, I'm going to move my BSG expenditures column right next to the Century column. So these are the two key variables that we're working with. So to do the difference in means test, Click on Data tab again, and then Data Analysis. And we're going to do a 2-sample t-test, assuming unequal variances. Okay, and we've done this before. So the variable 1 range, this time I'm not going to click on the label because I just want numbers in here. So the variable 1 range, let's make these smaller samples. I'll grab the first 10 people who rode the 50-mile route, and then the variable 2 range, I'm grabbing 8, I think that's 8 people who rode the 100-mile route. Okay, there's no labels. Go click OK, and here's the results I get. So the average expenditures for people who rode the bigger sample size, who rode the 50-mile route, is $735, and the average for those who rode the 100-mile route is $395. The t-statistic is 1.36. The two-tail critical value is 2.18, and there's about an 80% chance that these two numbers are different from each other. Okay, and what we're leading up to is a test for the differences in the variances of these two numbers. And so I got rid of the zeros and added the comma, so we can see that looks like there's a big difference in the variances. For people who rode the 50-mile route, the variance is an order of magnitude greater than for people who rode the 100-mile route. But what we want to do is test that to see if it's different and see if our unequal variance assumption makes sense. So data analysis, and F-test for differences in variances across two samples is the window that you want to open up. So variable 1 range, we're going to pick the exact same values. So 11 people who rode the 50-mile route, and then 8 people who rode the 100-mile route. I don't have labels, and so I just need to click OK. And so here is the F-test for differences in variances. This is a folded F-test, so you want to make sure that your F statistic is greater than 1. So that means you want to pick as variable 1 the group that ends up with the greatest variance. Okay, so it looks like the variance for variable 1 is about 12 times greater than for variable 2. The critical value is 3.64. F-stat is greater than the critical value, so if we're conducting a hypothesis test, then we're going to reject the hypothesis that the two variances are equal. And there's the p-value. There's a lot of zeros to the right of the decimal. So 1 minus the p-value tells us the confidence that we have in our conclusion here. And we're 99.85% sure that the variance for variable 1 is greater than the variance for variable 2. So that's it. If there's any questions about this assignment, or if anything doesn't make sense, send me an email. I'm not going to be in class tomorrow at 10 o'clock, but I will be around. I'll be checking my email, and I'll be able to answer your questions. So this assignment opens up at 5, and I think it closes a couple minutes after midnight on Friday. So make sure you get this thing done, and I hope you have a great weekend. Bye.